All right, welcome back to our second example in 3.4 on determining the validity of arguments in categorical logic using the Venn diagram test for validity. So our next argument that we're going to be asking whether it is valid or not is the following argument. It's the argument all S are P, therefore no S are P. Now, notice that this is a little different than the argument that we just went through above. In the argument we went through above, we had actual categories of English. We had mammals, we had things that are amphibious. Down here, we've abstracted away from some of that English wording, right? We're just using what you might call variables for categories, right? S and P just are variables that stand for categories. They technically stand, right, for subject and predicate. So if we wanted to, we could think about S and P as mammals and things that are amphibious in the same way we did above. So this argument, all S are P, therefore no PRS, that's basically identical to all mammals are amphibious things, therefore no amphibious things are mammals, right? So if it helps you to add back in the English to give yourself a real, tangible category to glom onto, go for it. But these are just categorical variables that we're using here for the sake of simplicity. All right. So now, that being said, the first thing that we have to look at, remember the first question we ask ourselves is, what are the categories we're dealing with? So the categories we're dealing with here look to be S and P. And notice they're exactly the same categories in the premise and in the conclusion, right? Same categories. Even though they're out of order, like we talked about in the previous video, the order here doesn't matter for determining what categories we're going to use for our Venn diagrams. They matter in terms of the argument, right? So we're asking, is an argument where the order of the subject and predicate, when the order is switched, is the argument valid? So that's the question that we have here. But for just creating Venn diagrams, our order of categories doesn't matter. So we just need to know that we have two and what those two are. All right, so now that we know it's S and P, we know that for our premise Venn diagram, which is the one that we're going to start with, we're going to have two big circles. And we're going to label one of them S. I'm going to put S on the left, and one of them P. And so now the question that we have is, to figure out what we do about the categorical form of the premise. So remember, there are four categorical forms. And the categorical forms are as follows. All S are P, no S are P, some S are P, and some S are not P. And so if we look at this, right, very clearly we see the categorical form here. It's quite obvious because, in fact, there's an all, right? There's an all right here. And there's not a no, right? There's no negation anywhere. So that means that our categorical form in this case is that all S are P. That's our categorical form. All right. So what do we do with the categorical form all S are P? Remember, all and no involve shading. So all and no are things where we are shading or removing possibilities. And some involves asterisks. The some and the some not involve asterisks. And that's where we're ruling in a possibility. So asterisks rule in a possibility. Shading rules out a possibility. All right. So since shading rules in a possibility, since shading rules out a possibility, we have to ask ourselves, what possibility are we ruling out? And the answer is, if all S are P, that means we're ruling out the whole area of S that isn't also an area of P. So in other words, since all S are going to be P, that means if we have any S's, they're going to be in this area because they're also going to have to be P's. And this is where we overlap with P, right? This is where the S's overlap with P. So that means we can shade or rule out this whole area of S over here where S does not overlap with P. So that's our first Venn diagram, pretty clearly and straightforwardly, right? It says, hey, any S that you have is going to be an S right in here. If you have S's, right? Remember, all SRP doesn't assume that there are actually S's out there, right? It could be the case that all SRP is true and not a single S exists. Think all unicorns are daisies. Could be true, right? But unicorns don't exist. Okay. And in fact, it's precisely true because unicorns don't exist. But that's another issue to set aside that we're not going to deal with in this example. Now let's go ahead and take a look at the conclusion Venn. So the conclusion Venn diagram has the same basic structure because it has the same basic categories. So we're going to put S on the left, exactly as we did in the premise, because we want our Venn diagrams to be as identical as possible. We're going to put P on the right, and then we have to ask ourselves about the structure. Now notice, the categorical form of the conclusion is no PRS, right? So it looks much more like this second categorical form right here, no SRP. It's like that one. Except, notice really importantly, the categories are reversed over here. So instead of saying no SRP, what we're saying is no PRS, right? That's kind of that's different, right? Because in our conclusion, we're saying something about P. We're saying something about the P's and whether they have this property of being an S. Whereas in our initial categorical form right over here, we're saying something about the S's and whether they have a property of P. Those are two different sentences, right? But as we noted previously, because of this little fancy no word right here, they both involve shading. And so they're both going to involve ruling out a possibility. So now we have to figure out what possibility we're ruling out. So let's take a look at our Venn diagram specifically over here. Now we have the idea here is that no PRS. So that means that we're ruling out the possibility where P's are S's. So we have to rule out or shade everywhere where a P is an S. And so that might become really obvious to you. We're shading right here. We're shading all the possibilities where the P's, so this thing, is also an S, this thing, right? And that's just precisely going to be the overlap between P and S. So when we shade there, we can double check our work and we can ask, okay, in this Venn diagram, is it the case that no P is an S, that no P are S's? And the answer is yes, because if you're a P, the only way to do that is to be over here, right? Is to be in this area. But to be in that area is not to overlap with S. So to be in that area is to be a P, but not an S. All right, so the last thing that we have to ask ourselves is we have to ask ourselves this question over here, validity. We have to ask, is this argument valid? And remember, the way we ask, is this argument valid, is we do that by checking whether there is information contained in the conclusion Venn that is not contained within the premise. So in other words, does everything in the conclusion follow from the premise by having no extra information that the premise doesn't contain? And the answer here pretty clearly is no, right? Because this information, that shading out information of the intersection in the conclusion is novel. It's not contained within the premise because we don't shade anything in the intersection in the premise, right? We don't shade anything in this middle portion right here in the premise. So that means there's novel information in the conclusion, right? There's novel info here. And so that means the answer to our question is no. This argument is not valid. All right, and so that brings us to the end of this example. Thank you very much.